Hello viewers, welcome back to my channel. Now look at this simple math problem. Okay, we are asked to show that this line is a tangent to this circle. Okay, there is a concept I want to bring for you before we start solving this. Okay, don't forget, in our previous video we have solved how to find the equation of a circle using the center and the radius, and how to find the center and the radius using equation of a circle. Now we are now in tangent. Now I want to show you something. Let's assume that this is a circle. Assumption. Let's assume that this is a circle. Now if we have that this is the tangent to this circle, let's say that this is a tangent to this circle. Okay, now and this is the center of this circle. Do you know that the line that draws from this point to this line, sorry, a line that draws from the center to that tangent is the same thing as radius? Is it not true? Yes, it's radius. Now this concept of showing that this is equal to this is just to find the distance from here to here. Okay, if you find the distance from this point, okay, you can find the distance from this point to this line, like the distance from here to here, and then you find the radius of this circle. If they are the same thing, then automatically we can now conclude that that line is a tangent to that circle. Okay, because the line from the center of the circle to that tangent is what we call the radius of that equation. Okay, so now let's go. So all we need now, if we can get this point is called h comma k. This is the center of the circle. So if you can find the distance between a point and a line, there's a formula for that. If you can remember, watch my video on straight line. You can remember to find the distance from the center to the distance from a point to a line. There's a formula for that. We'll come to that, but before then, let us find the radius of this circle and know what it is. Once the radius of this circle is the same thing as the distance from here to here, then we conclude that that this line is a tangent, because a tangent touches or passes, it touches any part of the circumference. Okay, so the concept, remember, the concept is just to find the distance from here to here and check if it is the same thing with radius. All right, that is just that. So let us go. The first thing is to find the radius. So we have that they gave us that x squared plus y squared plus 2x minus 8y minus 12 is equal to 0. I'll use the fastest method of solving it. We have different methods of solving it. We can use simultaneous completing the square method or the formula method. With the easiest one is the formula method. That is what I'm going to use here. You can watch my previous video if you want to learn the completing the square method. All right, so let me use the formula method that said x squared plus y squared minus 2hx minus 2ky plus c is equal to 0. Now if you compare this, you have that this is this, this is this, so this one goes to this. So minus 2hx should be equal to 2x. So if x take care of x, you are going to have that h is equal to 2 divided by minus 2, which is what? Minus 1. Okay, so comparing again, you see that minus 2ky is equal to minus 8y. So if y take care of y, I'm going to have that k is equal to minus 8 divided by minus 2, which is equal to what? 4. Then finally start comparing, c is equal to minus 12. Okay, but there's a formula for c. Don't forget that c is equal to h squared plus k squared minus r squared. It will not help us to get the radius. So I'm having that minus 12 is equal to minus 1 all squared plus 4 squared, then minus r squared. So this one can come here, this one will go here. So therefore my r squared is equal to minus 1 squared is 1 plus 16, then plus 12. Okay, so you see that everything is giving me this is 13 plus 12, that is 29. Okay, 29. So if you look at this, you see that r itself will now be the square root of 29. Okay, so we have gotten the radius as the square root of 29, and then the center, which is h comma k, the center which is h comma k is equal to, we got it as what? Minus 1 comma 4. Okay, now the next thing now is to get the distance between a point and a line. And the formula for distance between a point and a line is given by absolute value of ax1 over radical plus by1 over radical, then plus c over what? Radical. Okay, absolute value. That is the formula. Now the problem here is that our x1 and y1, okay, are the points we need. Okay, and that point, according to that circle I drew for you, the point there was the center of the circle. So this one will now change to our h comma k, okay, which we have gotten already to be -1 and 4. That is the point we are looking for. Then your a, b, and c is from this equation. So a is the coefficient of x here. So my a is 2 and my b is 5. Then my c is 11. Okay, you see, it's not difficult. So let us now get our radical. The formula for radical. All right, the formula for radical is given by plus or minus the square root of a squared plus b squared. Sorry, I'm using voiceover because I don't know what happened to my mic, so let's manage it. All right, so, and we use plus if c is minus, and then we use minus if c is plus, and in this case our c is positive, so we are going to use minus. Okay, so that is that for radical. So the condition depends on c. So we're going to have this is equal to minus the square root of my a is 2 squared plus 5 squared, which will give us minus the square root of 4. 2 squared is 4 plus 5 squared is 25. Okay, so which is giving us minus the square root of 29. Right, so now let us now substitute. We now have that d is equal to the absolute value of my a is 2, while my s1 is h, which is -1. Okay, -1 all over the radical, which is minus the square root of 29, then plus my b, which is 5, in bracket of my y1, which is k, which is 4 there. So I have 4, okay, then all over minus the square root of 29, then plus then my c, which is 11 over minus the square root of 29. All right, you close the absolute value. So let me clean this side so you will get it. Sorry for the voiceover, it's because of my mic. Okay, so now please subscribe to our channel. We bring you maths, physics, and chemistry. So I have d is equal to, when you multiply, minus will take care of minus. So I'm having a minus taking care of minus. I'm going to have positive 2 over the square root of 29. Then plus minus will give us minus 20 over the square root of 29. Okay, then minus again 11 over the square root of 29. You close. So if you now do the LCM, the LCM is square root of 29. So I'm going to have at the numerator 2 minus 20 minus 11. So you close. So this will now give us the absolute value of minus 29 over the square root of 29. You close. Now absolute value means it must be positive. So this is going to be, to remove the absolute value, I'm going to have 29 over the square root of 29. If you rationalize, you are going to have times with 29 over root 29. So which is going to give us 29 root 29 over 29, because root 29 times root 29 will just give you just 29. And then I'm going to have finally the square root of 29. And this square root of 29 is exactly what we got as the radius of this equation. Okay, so since the radius is the same thing as the distance, then we conclude that that line is a tangent to that circle. So thank you very much for watching. Please don't forget to like this video, comment, and then subscribe if you are new to this channel. Bye bye.